Okay, so in this problem, we're going to solve the trig equation 1 divided by the quantity tangent squared x plus 1 equals 3/4, and we want to find the solutions for all angles from 0 to 2 pi inclusive. And since we're going from 0 to 2 pi, that's an indication that we want to find the angle measures in radians, one lap around the unit circle. So the first thing we want to do is remember that when we see a square in a trig function, that usually clues us in that we're going to look for a Pythagorean identity. So if we head over here to the trig identity hexagon, we can recall that these triangles at the top, the left, and the right sides of the hexagon form our Pythagorean identities. So sine squared plus cosine squared equals 1. 1 plus cotangent squared equals cosecant squared. And then the one that we're going to use, tangent squared plus 1 equals secant squared. So tangent squared x plus 1 equals secant squared x. That's the Pythagorean identity from this triangle right here on our trig identity hexagon. So since tangent squared x plus 1 is the same as secant squared x, in our equation we can replace this denominator with secant squared x using that Pythagorean identity. And that 1 divided by secant squared x is equal to 3/4. Okay, next I'm going to go ahead and look at the secant here on the trig identity hexagon. And secant is diagonal from cosine, which that tells me on the hexagon that they are reciprocals. So cosine is the reciprocal of secant, secant is the reciprocal of cosine. So on the back to the equation here, we're going to go ahead and use that reciprocal identity that tells us that the cosine of x is equal to 1 over the secant of x. We're going to use that in order to replace 1 over secant squared x with cosine squared x. And so cosine squared x is equal to 3/4. Okay, now to undo a square, we have to square root both sides. So we'll take the square root of the left and the square root of the right, and that's going to get rid of the square. So we'll have just a regular cosine of x. And when you take the square root of a fraction, you take the square root of the numerator, which would be square root of 3, and the square root of the denominator, the square root of 4 is 2. And don't forget your plus or minus, because whenever you do a square root of a squared variable, you get two answers, a positive and a negative. Okay, next we want to get the x by itself, so we're going to need to do the inverse of both sides. So x is equal to the arc cosine of plus or minus square root of 3 over 2. And that's asking us to take a look at the unit circle. And on the unit circle, we want to find all of the angles from 0 to 2 pi inclusive, where the cosine, which is the x-coordinate, is either positive square root of 3 over 2 or negative square root of 3 over 2. So if we want to start by recreating the first quadrant of the unit circle, okay, this is in radians. This is 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay. And then for those of you that remember this pattern for generating your coordinates, you can follow along as we fill that in. So when you want to use this pattern to fill in the coordinates, you start on the outside here, the y coordinate, and we're going to start at the bottom and head up, counting 0, 1, 2, 3, 1, and then we're going to come back down with the same pattern. 0, 1, 2, 3, 1. Okay, then everything in the middle is going to get divided by 2. And then we're going to square root everything. So the square root of 1 is 1, and then we square root the 3. We square root these 2's. We square root this 3, and square root of 1 is 1. And so these are the coordinates for the special angles in the first quadrant of the unit circle. Okay, we want to find the cosine, which remember is the x-coordinate that has a root 3 over 2. And that would be right here at pi over 6. Right? Pi over 6 has a cosine of root 3 over 2. So x equals pi over 6 is one of the solutions to this trig equation. But if you recall, there are 4 quadrants, not just one, on the unit circle. And this first quadrant, everything is positive, right? So that's why there are no negatives here in our coordinates. And the acronym all students take calculus, that reminds us what's positive where. So in quadrant 1, all of the trig functions are positive. In quadrant 2, the sine and its reciprocal cosecant are positive. Quadrant 3, tangent and its reciprocal cotangent are positive. Quadrant 4, cosine and its reciprocal secant are positive, right? And that's all 4 quadrants. So our quadrants where the cosine is positive would be quadrant 1, which we just found at pi over 6, and quadrant 4. So let's go ahead and find our positive angle in quadrant 4. So here's pi over 6, that's our reference angle from quadrant 1. Since there's 2 pi radians in the whole circle, this would be 12 pi over 6. So if we go back into quadrant 4 from there, we have to subtract because we'll be going clockwise. So 12 pi over 6 minus pi over 6 is 11 pi over 6. And that would be our second answer for this trig equation, x equals 11 pi over 6. Right? These two solutions from quadrants 1 and 4 are finding the positive square root of 3 over 2 for the x-coordinate. Now in quadrants 2 and 3, cosine is negative because sine is positive in quadrant 2 and tangent's positive in quadrant 3. So we need to reflect our reference angle from quadrant 1 now over into quadrant 2, and that would be here. And so if the whole circle is 12 pi over 6, half the circle would be 6 pi over 6, and we're going to go back 1 from there, so that would take us to 5 pi over 6, and so x equals 5 pi over 6 is our quadrant 2 solution. That angle, 5 pi over 6, would have an x-coordinate of negative square root of 3 over 2. Okay, now we're going to look for the angle in quadrant 3. And now that we're heading in the direction towards the counterclockwise direction towards the angles from 0 around to 2 pi, we, instead of subtracting now, we need to add. So 6 pi over 6 plus pi over 6, our reference angle, gets us to 7 pi over 6, and that's going to be the fourth solution. So x is equal to 7 pi over 6 would also be an answer to this trig equation. Okay, so now we want to check all of these to see if they all work or if any of them turn out to be extraneous. So in the calculator, let's make sure you can see here, we're going to start by going to the mode and make sure that we're in radian mode, which we are. And then our first answer we want to check was pi over 6. So we're going to type pi over 6, and then the store button is up here above on. So store x, enter. And then we want to type in the original equation just like we see it. So we're going to need a fraction. So alpha y equals number 1 gets the fraction template. 1 divided by And then there's no notation on the graphing calculator for tangent squared x. So we have to remember that means to find the tangent of x and then square it. So we want the tangent of x, and then we square that quantity. And that's plus 1 in the oops, we want that to be in the denominator. Plus 1 in the denominator. Okay, and then to get the equal sign, we go to second math and press number 1 for equals. And we want that set equal to a fraction of 3/4. Now, whenever you use that equals from the test menu, that's asking the calculator a yes or no question. So we're asking the calculator, when you substitute pi over 6 for x, does this make a true statement? If it is, if it checks, the calculator will respond with a 1. If it's false, if it doesn't check, the calculator will respond with a 0. And we got a 1. So we know that pi over 6 works as an answer. Okay, now we're going to try 5 pi over 6. We're going to store that as x. And then rather than retype the whole equation, you just arrow up to it so it's highlighted. And when you press enter, it just rewrites it for us. Press enter, and 5 pi over 6 also checks. Okay, now we're going to check 7 pi over 6 by storing that as our new x. Arrow up to the equation, press enter, and 7 pi over 6 also checks. Okay, last but not least, 11 pi over 6. We're going to store that as x. Arrow up to the equation, and again we get a 1, so 11 pi over 6 checks. Okay, you want to always check your solutions, because sometimes in the examples that we've been going through, if you recall, you'll run into an answer that you end up on the calculator with a domain error. And those, it wasn't that we had made a mistake in our algebra, it was an extraneous solution. Remember, there are solutions sometimes where you have to throw them out because they don't work when you check them in the original equation. But in this example, we ended up with 4 solutions, all of which checked: pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.